Good afternoon, everyone. Thanks very much for coming along. It's really great to see so many people here, and I think this is the first time we've presented at TechEd, so it's really nice to welcome you all along. I hope you've had a chance to get it onto stand and have your photo taken with the example of New Zealand innovation and high-performance technology we've got down there. I'm not going to take very long. My name's John Ashcroft. I look after the innovation function at JOOB Software, and I'm really proud to be able to come here today and open for Roger Harkeen, who's going to talk about the technology behind the JOOB product. So I'm just going to do a very quick overview, very quick look at the architecture, talk about one of the little examples we're doing with it, and then Roger's going to get into the sort of meaty stuff. And I believe there's a live demo and real code to be seen. So just very quickly, for those of you that aren't familiar with JOOB Software, which is the company behind JOOB, we operate in four main areas, and the first of those is high-performance technology, and that's the group that's producing the JOOB technology product. We then use that technology ourselves to build applications, and those applications are primarily in 3 LOBs, which you can see up there. So what is JOOB? Well, JOOB is a high-performance solution framework. What we do is we start at the bottom there, so the little blue circle is the actual data store, the database. So in broad terms, you can think of that as performing the same sort of functionality as, say, a SQL Server or an Oracle database, a relational database. But the difference is that the JOOB technology is implemented using object-oriented technology, which gives you some advantages in some environments. Layered on top of that is some modules that we're releasing which are built to integrate in with the JOOB Storage Manager and provide you with common functionality either horizontally or vertically. And I'll cover a little bit about that in a moment. And then on top of that, of course, you've got the whole .NET stack, Visual Studio environment that lets you take all the advantages of that environment. So it's all nicely integrated. It's all a VS product. One of the ways we're using this is as a problem solver for where you've got an existing environment, enterprise systems, and you want to do something quick, fast to market, building on information that's kind of available but not able to be pulled together. So this can be very nice sort of complementary operational data store, holding the corporate information, not necessarily the master copies of it, but providing you with a rapid application development environment that you can build on top of. So we start at the lowest level with the direct database equivalent, and what we're doing here is taking the in-memory class model, the objects and relationships we've already got in .NET and C# or whatever, and writing them to disk as objects and relationships, which means it's very fast to pull the stuff back out, and particularly to reassemble the object model means you don't need to do the object relational mapping or mentally or whatever yourself deconstruct the object model into tables and rows and columns, tables. So we've got the services. Then we've got what we're calling JOOBlets, which is kind of cute, which is the little building blocks that we're supplying. So one of the first ones there is the mobile services, and I'll talk about that in a moment. And then sitting on top of that is the applications and LOB stuff. But of course, this isn't restricted to any particular LOB. That's the ones we're using it for. So just looking at the data store in particular, on the left side, the JOOB object storage, basically the in-memory class instances and all the relationships between them are seamlessly persisted to disk. That means that when you come to bring it back, if you've got a complicated sort of set of relationships, something like bill of materials, parent-child relationships all over the place, then we can reassemble those very quickly. It also means that there's some ways that we can do caching and distributed architecture, which Roger's going to cover in more detail, which gives us an advantage. On the right-hand side is the traditional data mapping, where you're deconstructing the object model into relational storage, and whether you do that through some form of ORM or do it manually, there's always going to be that overhead. So, interestingly, and some of you may be familiar with Jade, the core underlying technology, which is what we've taken and re-implemented in the .NET environment, is already in use in a large number of quite respectable reference sites. So we're pretty confident and happy about the performance reliability of this product in its existing environment. What Roger will share with you is some performance figures which I think are quite surprising when we moved into the .NET environment running full 64-bit, etc. Just wanted to very quickly touch on the mobile stuff we're doing. So we're releasing a framework which lets you build mobile solutions that can be connected, and we're offering it as a service, but of course anyone can get the code as well, where you can pull enterprise data into the cloud, run your mobile framework, and then feed business transactions back to the enterprise systems. The advantage, of course, of that is that it asyncs the processor. We can upgrade the left-hand side without having to worry about the right-hand side and so forth. Provides a very clean way to implement a mobile solution, and at the same time, because of the solution framework, we're providing all the common plumbing and stuff that you need to implement on every mobile solution without having to rewrite it. So there's only a relatively small amount and shrinking code that needs to be customized for each application. So that's one example of where we're using the flexibility of the product to deliver an actual application benefit. So, some of you will have seen the JOOB guy and our tagline, dangerously fast. This thing does perform. What I'd like to do now is hand over to Roger for the technical view of the product. Thanks, Roger.
Thank you, John.
Yeah.
Thank you, John. Good afternoon. My name is Roger Harkin. I am the CTO of JOOB Software Corporation, and I lead the team that designs and develops the JOOB product. During the rest of this session, I will be covering several technical aspects of JOOB with the objective that by the end of it, you will have a good appreciation and understanding of the algorithms that we use and the characteristics of JOOB that make it a remarkably flexible and efficient platform to address the sort of applications that John was talking about. So let's see the agenda that we have to cover. There is a lot of ground to cover. The agenda is pretty much divided in 4 parts. First, I will be talking about an overview of JADE, what are the technical elements of JADE, the components, how they fit in the Microsoft ecosystem. Then that will follow with the creation of a little database, and then we'll write a console app to populate it so that you get an idea of the environment on how we have integrated JOOB into Visual Studio. The second part is, after that, is concentrating on some of the strong points of JOOB. Why JOOB does what it does very well. So I'll be covering aspects of architecture, the distributed processing architecture, and modeling, data modeling aspects of JOOB as well. I will show a couple of test case scenarios where you can see the characteristics of the JOOB engine performing, and we contrast it with other more traditional databases. Finally, I will be touching on some of the features that we are working on, and that they are tied back to some of the frameworks and JOOBlets that John was mentioning before. Okay, so first, the JOOB integration into .NET. Let's divide this in 2 parts, runtime and development time. At runtime, we have, at the center of all of this is JOM, which is the JOOB Object Manager, and you will be hearing me referring to that guy a lot, because that's the core. That's where all the goodies are. Where the main features are implemented. Now, that's the engine. That engine, and John mentioned before, is not new. This is not new technology. This is proven technology. We are running serious businesses out there with this technology. What we have done for JOOB, and that's the existing JADE product, what we have done for JOOB, we took that technology, we took the engine, put it on the floor, overhauled it, put it back together, rewrote important components of it, and made it .NET friendly, Microsoft friendly, so that it can fit better into the Microsoft environment. Okay, so that's JOM. So how do you interact with JOOB? So we have developed several extensions to Visual Studio. One of them is the implementation of the JOOB modeling language. So it's a very simple line. You'll see it in a moment. It's purpose-built just to define your object models. And the database designer will go into Visual Studio, define that, and out of that activity, there will be two components produced. One will be a description of your JOOB database that will be loaded into JOOB. And the second is an interface, an interface assembly that will be used when you program in .NET languages for that database. That's where the database programmer will come in. So this was the database designer, and then the database programmer comes in, and you can use any, of course, of the .NET languages and technology stack. At runtime, we have some other components. One of the important components here is that we provide, because this is an object-oriented database, we do the inverse of the OR mapping tool. We now map an object database into a relational view so that tools like ODBC, tools that use ODBC can come and query that database. So that's very powerful. And for the system administrator, we have the JOOB System Management Studio that has two flavors. One is integrated with Visual Studio as an extension, and another one is a standalone program. And of course, we have JOOB utilities to do database stuff, backups, online backups, and so on. And also, you can use a scripting language to interact with the JOOB environment. Okay, before we get into the demonstration, I just want to emphasize something about the programming philosophy of JOOB. How many of you have experience with databases other than relational databases? Oh, that's a nice number. So you will see here that JOOB does certain things that are different. A number of the object-oriented databases out there, what they do is they persist a program. So you start with the program, and then you decorate the program, and it transparently persists. That's one approach. The other approach is you build the database, and then you program to it. That's the one that we chose to do with JOOB. Because in our view, the data model is central. That's first. It's not the program, it's the data model. That's similar to what you do when you work in a relational database. So we take that approach to the object-oriented database. So then, of course, they can be accessed by more than one program. And we have an interaction with JOOB objects that is as natural as possible, so that you feel at home working in all languages with this data store in a transparent manner. You can achieve that with some object relational mapping tools. Difference with JOOB is that we don't take the performance hit that most of those tools take. So with JOOB, we are taking the best of both worlds. We're taking the seamlessness of the object manipulation and the speed of going straight to the object database. Another aspect that you need to keep in mind when you are writing a JOOB system is that it's easy to forget you are working with a database underneath, so there are considerations that apply to databases but don't apply to programs. Okay, so let's go into the demonstration. I will be showing three things. The objective of the demonstration, the first thing is for you to get a feel of the plugin that we did for Visual Studio 2010. Then when I define the system, I will be talking about JOML, the JOOB object modeling language, and the certain design decisions about it. And once we have defined our little schema, then we will program to it. Okay. So let's start creating any project here. And the first thing you notice is that because we have a plugin, we have here the option of making a JOOB project, a JOOB solution. So we select that we want a JOOB schema project, and we're going to call that Demo 4. I need to increase the resolution. That's better. Okay, so it created a solution for me, and it created a YOML file. It already put some stuff on it. Just I'm going to talk about the top line first. In JOOB, you have this concept of schemas, which is similar to namespaces in .NET. A schema is a collection of classes. And what you do is that when you create a schema, you always make it subschema of any other schema, and you inherit all of those classes that the super schema has. So every JOOB schema, by default, inherits from the root schema. That name is taken by us. And in there are a number of classes for collections, a number of functionality that we provide. So that's what it's saying there. The schema, say the super schema is root schema, and the next one is demo schema. And don't pay attention to the rest. The rest is about the physical characteristics of the database, what's the name of the database, what are the files, and so on. So let's get into creating some classes. So let's create a class first. Let's create a company class. And let me get my glasses to have a better look at this. Company class, subclass of object. Okay. Again, every class in JOOB is a subclass of the object class, not to be confused with the .NET C# object. This is the JOOB object. And then we define a property in it. So we have a string. You can see the IntelliSense. I mean, all the amenities that you can expect in an extension to Visual Studio is there. So we have our first class. That's an object. Then we create another class. Let's call it product. Again, subclass of object as well. And let's put a property. Let's call it code and string. But this time I'm going to bound this string with a length. I'm going to say the string is length 20. You'll see the reason for that in a moment. Okay. So I got two normal classes. Then I need to create a special class, which is a collection class. Collections in JOOB are first-class citizens, so they are very important. So every collection in JOOB needs to be defined as a separate class. So I define a class where I'm going of a collection class. I'm going to call it product dict, where I'm going to store products, and that's the membership of that collection. So I'm saying product dict will contain products, and here the plugin gives me the option of making subclass. It's a good guess. Is of member key dictionary. Member key dictionary is the superclass of all the collection classes which keys are obtained from a property of the members. So in this case, I'm going to say that the key is code. And because it is a key, code is a key, I needed to put a length on it. The name on company is unbounded. Okay, so I got now 3 classes, and these are the ones we're going to use. But the other thing we want to do, we want to populate. Sorry, I don't know that product singular. Okay, so the next thing I want to create is a one-to-many relationship between company and products. So one company, many products. So I'm going to create a property here called all products of type product dict, which is my collection that I just created. So they're going to be ordered by the key of code. And we want that, so that one end, an inverse, a relationship will have 2 ends. Normally, I'm going to mention in a moment a case where there is more than one end. But usually you will have 2 ends. So at the end of, at the side of company, we have all products. And in products, we're going to add a property called my company of type company. Okay? And I'm going to say that there is an inverse here. the inverse of my company here is in company, of course, and it is all products. Okay? So that's all. So what's going to happen is that when I assign a company into a product, it will automatically insert that product into the all product dictionary of the company. So it will do that automatic relationship maintenance. Okay, so I'm done here with my model. Then I need to do two things. The first thing is to generate the assembly that we're going to use when we program to this later on. So just mentioning quickly here, you see this file, JOML. So what we did here is we generated some C# code in the back, which is will be used to create the assembly, and this is the domain model for the application that will be used later on. So we don't need to pay attention to that one. All we need to do is to build it. So build the solution. And the next thing we're going to do is to load this into the JOOB database. So for that, we go and select deploy, demo 4. And what it did, it opened a JOOB database, loaded the database, and closed it with the completion of the load. So we are done here as far as creating my schema, creating and the assemblies, and to load it into the JOOB database. Okay, so the next step is let's go and program to the thing. Let's go and do it in a different place. Let's create a new project here. This time I want to choose a Visual Studio, a Visual C# console app. And we're going to call it demo app 4. Okay, there's a console application, C#. Okay, so we're going to start programming now. We will populate some objects into that schema that we created. So the first thing we need to do is we need to add some references to this project. And there are two references that we need to add. The first one is a generic assembly that is used every time you're going to use JOOB independently of the database. So that's generic. And the other reference is the one that we just created before. And we're going to do a browse here because I just created it. With demo 4. There it is. That's the one that was created from the C# that we generated from your JOML definition. So we have now the two references, and we're ready to start programming to this. So we need to declare them here for C#. So jsoftware.joob.client, that's my first one. And the other one is we use root schema.demo4. Okay, that's it. So I'm ready to go to start creating some objects. What we're going to do here is the first thing we're going to do, every time we're going to go to JOOB, we're going to create a JOOB context. Is the main vehicle from the .NET application to the JOOB database. So every operation that you do, you need to do within a context. The thread of execution that you have acquires the context, and we start working with it. And being good C# citizens, then we put it in a using statement, so everything gets disposed at the end. So then, because we're going to update the database here, let's get another player, which is a transaction. So once I have a context, this JOOB context, then I can go and ask the context to begin a transaction. And now I am in transaction, and at this point I'm going to start creating objects. So let's create a company. Company, CO, equal company. call it company one. Okay, that's all. I created my company. I set the name on it. Just normal C# stuff. Then I'm going to create product. Product one. Put that code in there, like I said. Okay, let's create two. Let's call this product 2. And let's call this ABC. Okay, so I have created 3 products. Three objects, and now I'm going to create the relationship. Remember the one-to-many relationship from company to product? So what I need to do now is to say product1 dot my company equal to CO. So that will insert product 1 into the dictionary, and also product 2, let's say it's in the same company. So we go same company equal CO. Okay, we're done. I would like just to make sure that we commit the transaction, right? So after that, what we want to do is to go through the dictionary to make sure that the objects were there. So we're going to do for each in there. For each processing of collections in JOOB, it's just normal C# again, and we're going to say code, not prod. Okay, so we're going to iterate through the products in the dictionary, and going to print out the code. So we should end up with 2. So we're ready to run this thing. One final detail is that this application could run with a number of databases that have the same schema. So I need to tell the particulars of which directory, mundane stuff, like what directory the things are in. So for that, we need to add a configuration file into the solution. And so I have one already, and I just need to change this name here to demo4, which is the name of the database that we have, the name of the schema. Enter. And let's step through this. At this point, we open the JOOB database. So we start stepping through this. Created a company, created a product, set the 2 inverses, committed the transaction, and we should go twice to the products. And just to prove that, there you go, ABC. Notice that we created ABC second, but because it is the key is the code, so when they were put in the dictionary, they were arranged properly. Okay, so that's the application running. And one last thing I want to see if we can show here. What I went to there is a JOOB Explorer. So this is another extension to .NET Visual Studio 2010. So you're working, and then I want to verify through a different way that my objects are there, not just through code. So I have the generic inspector that I can go, just like you do in SQL, and I can go, and I can see here, demo4. Look, I have a number of schemas that I have loaded in this database. So the one we're interested here is in 4, which is the one we have been working on. So there you go. You have collection, there's company in there. And I say, all instances of company. So it gives me the company 1, that is the one I created. So I can drill down on this and I say inspect in a new tab. So it gives me the string, the name, and there you go. That's the all products dictionary sitting there. So I can inspect that one, inspect a new tab. So those are the two entries, the keys, codes, and these are the internal object identifiers for the products that we have in there. Okay? So that's another way of looking at the system. So that's all I wanted to show in the demo. And let's go back to the presentation. So I think we're doing pretty good on time. But I get carried away at times, so I'll be warned. Let's see. Okay, we went to the... Now what you saw was base JOOB. That's simple collections, inverses, so you get the flavor of that. Now, getting into certain areas that are specific for JOOB. And we're going to get into the modeling extensions. And I won't mention all of them, but I will. The one I want to mention at this point is one called key path. Okay. In a couple of slides. Okay. Let's start with two inverses. Remember, we said a relationship had two endpoints, so we had the single and the multiple. So it happens. This is where JOOB starts being different. In a relational database, you will have tables and you have indexes and all that. There are no indexes in JOOB. Your collections are your lifeblood. Your collections are it. So collections are the arteries of a JOOB database. So you better set those in a proper way, and that's what gives the speed. Because when you're running, you're just traversing collections and chasing references. So you are getting to that very quickly. Not only that, collections, unlike indexes, indexes span the whole table. Collections, you control the collections. You can have a typical JOOB system, a well-designed system, will have a number of small collections. And you want to keep them small for concurrency reasons that I will be mentioning later on. So you leave those collections already in the position you want them to be. So in this case, you have that we have a class client that has a reference to my company. But in company, we want to set two collections, not only one like we did in products. I want, when I set my company into this client, I want that client to go in two collections. One is all clients, and I know that is keyed by name. And the other one is all clients by client number. I know that its name indicates, I know it is keyed by number. So one operation, I get the two collections ready to go. So I can traverse either way. I got 3, 4, I can have as many as I want. Also, I can have multiple keys in the collection, member keys. In this case, this client by name back number, which has clients as members, has the first key is name. The second key is my bank account dot number. That's a very interesting key, because we are using here a feature called key paths. So what happens is that the key is not coming from client directly. The key is coming from an object that client references to. So in this case, so we go to the bank account and we get the number. So that's very powerful to get into data later on. And of course, one thing I haven't mentioned here, when collections change, when the keys change, of course, we are maintaining those orders and dictionaries. So if you come here and you assign this client to a different bank account, we are going to get the number from the other one. So it's all done automatically as you go assigning. Okay, that's very flexible. And this one I like a lot. Let me introduce the concept of condition in a JOOB database, a JOOB model. So what happens here is that we have a client, and we have a property balance of decimal, blah, blah. Okay, I haven't mentioned, but JOOB has all the typical primitives, integers, 64s, integers. One of them is decimals. So there is balance. And we have this concept of a condition. So JOOB will evaluate this condition at key points. And the condition says that when balance is less than 0, then it is true that the thing is overdrawn. But that's a condition I can use. And you'll see in a moment how I can use that. So that's a flexible modeling. It allows me to express something about my data that you will recognize later on. Okay, what can I do with a condition? Then I define here 2 collections out of company. One that says all clients, and it's of type clients by Dick and so on. And I have another one called all overdrawn clients. But this one is constrained only when it's overdrawn. So what it means, when you set the inverses, it will set the first one because it's unconstrained, and it will set only the second one for those members that meet the condition. It's overdrawn. Okay, but the actual beauty here is that as you change balance, even when it is not a key, JOOB will track that you are changing balance, and it will take the members from in and out of the collection as balance changes. So that is being maintained automatically behind your back. That means that when you go later on and you want to do a quick traversal of all overdrawn clients, there is no calculation to be done. It's already cooked. So you just go to that information. So it's very, very powerful. This is a common pattern in JOOB. What you will have, remember I was talking about having kind of a smaller collections because you want to be agile, and you will see later on why it is good to have kind of smaller collections. So that means that you will play with those conditions, so you know what you're dealing with. So you will go through those collections that have already the characteristics that you want. Okay. How are we doing with time? So let's now move on into distributed processing, which is this is the fundamental paradigm of JOOB. What gives JOOB what it does. So until now, we have been talking mostly about modeling, static stuff. So what happens when we crack this system up? Who are the players? Who does what? So a JOOB system is fundamentally a collection of nodes. It's a distributed system collection of homogeneous nodes, except for one, which is more homogeneous than the others. And this one is the server node. And the server node, it has a special roles, and one of the roles that it has is that it takes care of the database. That's the one who takes care of the persistent objects. Every other node, we call them client nodes or application servers, they run a copy of JOM, the JOOB Object Manager, the main engine. So you could think of this one, for example, in terms of .NET, this will be an executable, a process, an AIS process, a background service, whatever. So what happens here, each node, at the center of each node, there is a cache of objects. So what's happening in objects, a node starts working and it starts requesting objects from the server node. So it does request like get objects, put objects, lock objects. It does a number of operations, bring objects in groups. So it's all of this happening automatically. So we have some very smart algorithms in there that we have grown over the years to keep in cache those objects that are going to give you more value. Because, of course, a cache by definition is a restricted resource. So that cache is maintained automatically by JOOB. And when you have a working set of objects loaded in your cache, that means that we can do quick operations because we don't need to go anywhere to get that data. That data is already cached. And in that node, you can have several threads of executions. Remember context? We were using context in there. So a context is used by a thread of execution when you do an operation in JOOB. A node could have 100, 200 concurrent threads working out of the same cache. So part of the algorithm of the cache is to be smart enough to share those buffers that can be shared and to restrict those buffers that you cannot see yet, because if you are working in a transaction, and before the transaction commits, all of those objects that you have modified or are not visible to the other threads. That will be dirty reads, and we get into all sorts of problems. So what JOOB does is that when you are in transaction state, it collects all of those changes in the cache itself. It doesn't duplicate them. It doesn't put anything special, anywhere special. And through a mechanism called transaction isolation, when you commit the transaction, all of those collections have been maintained, objects that have been created, and we do in a group operation, we go to the server and we just have the transaction. So the idea with JOOB is that the client knows do as much work as possible. We interrupt the server as less as possible, as little as possible, and we avoid doing trips, hence the catch. Okay, so the server does those object requests. There is a concept of notifications as well, which is quite important. You can have system notifications. You can say, I want to know if this object has been deleted, created, or modified. So you get a cause event, like in .NET. But the criteria for this event is a global event. So if anybody somewhere changes something around here, let me know. So you get called back. And the other function that is done there is one called cache coherence. This is very important because there are a number of cache systems out there that are do-it-yourself sort of caching. So you say, put your stuff in the cache, but you need to take care of it. Because that's the problem with cache. They are very good, but as soon as they start changing and you are not careful, then you have a stale cache, and it will do more harm than good. So one of the things that JOOB does is maintain that cache automatically for you. So that cache is kept automatically. It's always coherent. Okay. So that's another feature of JOOB, cache coherence. Okay, let's get in now a bit inside what happens in that node and the interaction with .NET. In the interaction with .NET, here we have a Windows process, and when you are this node has two parts. It has a managed code part and an unmanaged code part. The unmanaged code is the good old JOOB, and this is your .NET application. So one of the things we do is that when you are working with JOOB objects, we don't materialize the whole object. We work with the concept of proxy object, which is a design pattern that some of you will be familiar with. So what we do is those objects that seem like the real thing for you, but they are not. They are facade objects, they are proxy objects that are manipulating behind the scenes an object buffer, which is where the real data is. So JOOB is maintaining all of that back and forth. The important thing for that is that these proxy objects they are tiny objects. So you will not consume your garbage collected managed memory by a lot of objects that you just went and got a couple of properties out. So these objects are created quickly, and sometimes they go in generation 0, and then they get collected again. Not so with the object buffers. Remember I mentioned that the object buffers in the back are being managed by JOOB, and they're very, very well looked after, those objects there. So you can see that there may be an object buffer here that doesn't have a proxy at the moment, but it's good. It's sitting on cache because we know it's good to have it there. It has an access pattern, and we want to keep it in there. So the other characteristic of this cache not only is maintained automatically, that's different to other caches. The other important thing that it is an in-process cache. A lot of caches out there are out-of-process cache. So you need to take your object, you serialize it, you put it there, you bring it back, and look after it. So in the case of JOOB, no serialization, no going out of process, everything is there. Okay? Quite important. Okay, now to one of my favorite parts. If you're going to take something today of the characteristic of JOOB, this is it. Collection algorithms in JOOB. Remember I said the collections are your lifeblood. It's how you navigate the system. So what happens here, that collections in JOOB are distributed. That means that when you look in a dictionary or when you maintain a dictionary, It doesn't happen on the server like you will have happen in a traditional database. You work in a traditional database, everything happens on the server. So the client is just prepares the work, is passive, put it there, and the server has to do all of this work. In the case of JOOB, fundamental to it is that we don't do that. That's why you want a smaller collection. So we bring the collections into the client. You have a nice cache, so most of your collections will be sitting there. So you are doing searches, you're doing updates, you're doing all of this, and you're not leaving the node. You're not going to the database at all. So that gives you a lot of parallelism. Not only that, we have sophisticated algorithms to work with the volatility of the objects. In JOOB, there are three kinds of object volatility that give us a hint about how to look after those objects in cache. There are volatile objects that are likely to be changed at any point. So the priorities for read and write are treated the same. There are stable objects where you say this object is not likely to change much, like product catalog and things like that. You change it now and then, but not that frequently. So those are stable. So that we have a different algorithm to modify them. We favor reading over the infrequent writing operation. And then finally you have frozen objects. Sometimes you did already say you did an order, you have the order lines and all that. Nobody's going to change that. So you can freeze, that's frozen. That collection never going to change. So that can be sitting there in cache. We don't need to check it again. We don't need to keep it coherent. It's done. Okay? So look at this. In this graph, we have collection 1. Not only that, the collections not only kept several collections in JOOB, but we keep the collections, the parts of the collections that you're using. So you could have a large collection. For example, here, collection 1 has 3 parts. A collection is a composite object. It's a complex object. It's made up of collection blocks and so on. So in this case, we were doing lookups in collection 1, but we only require part of the B3. These are done with B3. So part of the B3. So these other two to the right, we don't need them. So we'll bring them when we need them. Collection 2 has been brought in its entirety. Collection 1 here in another node, it has a different access pattern. It's now this block the one that has been used, and the other 2 blocks are not being used. So it all depends. So each node will be working in a different fashion. Okay, let's move on. So those are aspects of distributed processing. Now let's look at some of those aspects of distributed processing in some extensions to collections. So these are methods that are above the normal method that you will find in a collection. So the first one is a get at key, a start at key, starting a key. So remember, these indexes are already cooked. We don't need to optimize anything here. So you say, I know I want to start at this key. So you go straight to that, and you iterate from there. So in this case, we do first instance of company or clients, and then that's the operation. So from there, we are going to iterate through with dictionaries starting at that key. Okay. Another operation. This is one that is quite good. There is a merge operation for collections that we have added. And it goes like this. Remember I've been talking about, okay, keep your collection kind of small and so on. Okay, you might say, oh, that's very well, but what happens when I need the whole thing? Because at times I want the whole thing. For example, imagine that I have, in this example, I have savings accounts and check accounts. They are in 2 different collections because that's how I work them separately. So I don't want to mix them. But now and then, for the end of the month or for certain special processes, I need to see the 2 of them ordered by the keys, merged nicely. Not a union with an order by, but just nicely merged as they are. So what we do here is we do this operation of merging. So I say query saving accounts merge with check accounts. So query now has a view of the two collections, and it's a lazy evaluation. So it's only when we start iterating that collection that the members are going to be pulled from each index or the other. it will do the matching, it will match the keys and it will feed them in the proper order. And you can have, we could merge another one and you could merge several collections. So, and then you have now, for that particular operation, you have a global view. Okay, so what, just to give you quickly, running out of time here, a flavor of some of the results that we have obtained doing experiments with all of this distributed stuff versus a traditional database. So when we put modeling, distributed processing, caching, all of that stuff that I've been talking about. We took a simple query over a query simple table, and we run thousands of queries in hundreds of threads. So we have concurrent execution of queries. So what will happen here, and this line here is a relational database. Could be any relational database as long as it has a centralized server paradigm that I was explaining before. So, and this is JOOB. And what the take-home here point is that as we increase the number of concurrent queries, JOOB is scaling better than the relational database, and that's very reasonable from all the things I've been telling you, that those queries are being distributed. So we are not hammering a centralized resource, so we are dividing as much as we can. So that's the result of that. So that's a simple single table query. Then we put a more complex query, and this one has 6 joins, and similar thing. What is important here is that these tests were on the same machine. We are working back in the benchmark laboratory at JADE in distributing now in different machines. So we expect that divergence between those two lines is going to grow. So I'll tell you when we find that out. Okay, so that's just an example of a couple of tests that put in action those characteristics I have been mentioning. So just to summarize on JOOB, we have integrated Visual Studio, a natural interaction with .NET objects. You saw how we program our simple applications. High level of modeling flexibility with key paths, multiple inverses, conditions, all of the stuff we have seen. Unique performance-oriented options like merges and key paths and so on. And a scalable architecture by distributing. Okay, so that's what we have, what we call now in JOOB phase 1, which is I'm going to spend the last 5 minutes talking about futures, things that we are starting to look at. And that is in line with the JOOBlets that John was talking about, when we use JOOB as an operational store. So and this is it. There is a new generation of applications out there that are waiting to be written, and that they're waiting for the facilities to be more accessible for them. So this insight that we have here, we have 3 main components that we believe are going to be required and quite useful to crack those applications. The first one, of course, at the base of it is JOOB, the operational store, with all the characteristics that I have been talking about. So, because the other one is computational intelligence, and I could talk for a long time about this one, but just want to scratch the surface about it. What's happened is that there are a number of algorithms that some of you might be familiar with, intelligent agents, those listed there. They are not particularly new. They belong to a branch of artificial intelligence called connectionism. And what they share is that they require a lot of computational power. They are called free model estimators. So it's very quick to build a model around this. But they are hungry, and they need to churn a lot of information, a lot of data, and they are right there for parallel processing and distributed processing. And that's why these algorithms that are not new are having a resurgence right now, because those facilities are there. So intelligent agents is They are units of execution. Agents are units of execution. They have their own state. They are independent, and they communicate with each other through message passing. They don't have a full knowledge of the whole world. They have a limited knowledge. And what happens is solutions get achieved by the emergence of behavior. So by having a lot of agents acting in their own manner, you have an emerging phenomenon. The opposite of that is a centralized global plan. So every agent has its own plan with its own local information. So the other technologies are used to drive how the agents make decisions, and you can use machine learning and genetic algorithms and so on. J Software Corporation is one of the founding partners of the New Zealand ICT Innovation Institute, based in Canterbury. For the last 2 years or so, we have been involved in a project of using intelligent agents for the optimization of containers movement inside a port. So one of the applications we have in JADE, as part of the portfolio, is in the logistics space. So we have been working with the Port of Otago and 3 universities experimenting with this sort of this concept. So we are now going to ramp up this sort of research to get JOOB some jobs that it will be good at. The third component here is the Microsoft platform. And of course, .NET 4.0 is great, WCF is great, but the one we are really looking at is Workflow 4.0. Some of you might be familiar with the fact that Microsoft rewrote Workflow for 4.0. The part of Workflow that interests us is not just the diagramming on the nice diagramming. The part that interests us is workflows as services, where your programs become data. And that sort of a computational paradigm fits nicely with agents, which fits nicely with the distributed processing characteristic of JOOB, where we think that those 3 components are going to be synergetic in the application for these new kind of problems that we're trying to solve. That's all I have to say today.